Okay, so today what we're going to be talking about are surds and some of the different functions that we can do with surds. So the first thing that I'm going to talk to you about are adding and subtracting surds. And the way that we add and subtract surds is very similar to what we do when we use regular algebra. Okay, so for example, so I'm just going to write some notes here. Oops. Similar to algebra. So the surd you can treat in the same way as an X or Y. Okay, so what this means is to be able to add or subtract surds, we need to have the same surd in the term. So let's look at this first example here. This example, we've got 4 different terms. So each individual number here, this is one term, second term. Okay, we've got 4 terms here that we're trying to add together. So the first thing we need to know is that we can only add or subtract the surds together that have a surd in common, okay? So for example, in this example, this surd or this term here has a root 10 in it, and this term here has a root 10 in it. So we can simplify those two together, okay? So we've got 9 lots of root 10 here, and we're subtracting 1 lot of root 10, which leaves us with 8 root 10. So the second 2 numbers here that we've got 5 lots, negative 5 lots of root 5, and we're adding another 8 lots of root 5. So we've got negative 5 plus 8 is going to give us plus 3 root 5. Now we can't simplify this anymore because the 2 surds here in these 2 terms are different surds. So we can't add them together. Just like if we had a y term and an x term, we couldn't simplify and add those 2 together anymore. Okay, so let's look at the second example here. Now the second example that I've got here, all of the surds are written as fractions. So the first thing that we need to do, and that we need to remember when we're adding fractions together, is that the denominator, this bottom number on each fraction, needs to be the same. Okay. All right, so in this case here, what we need to do is we need to change, I'm going to change the colour again. We need to change the denominator on all 3 of these fractions so that they have the same denominator. And the way we do this is that we have to multiply each term, okay, each one of these 3 terms, by a number so that it makes the denominators the same. So the way we do that is we're looking at these 3 numbers here, 2 and 3 and 4. And we want to find a number that has 2, 3 and 4 as a factor, okay? So the lowest possible number that has all of 2, 3 and 4 as a factor, okay? So the first thing we can do, for example, is look at 2 multiplied by 3, okay? That's going to give us 6, but 4 isn't a factor of 6, so that's not going to work. If we look at 3 multiplied by 4, that gives us 12, okay? 2 is also a factor of 12. So all 3 of these numbers, 2, 3 and 4, are all factors of 12. So what we're going to do is we're going to make the denominator of all of these fractions into 12, okay? So the way we do that, the first number here, the first fraction, we have to think about what we're going to need to multiply it by to get the bottom number to be a 12. And we need to multiply this whole fraction by 6, okay? So what we're going to end up with is 6 multiplied by root 10 over 2 plus, now to get 3 into a 12, we need to multiply that by 4. Root 10 over 3. And then we're going to add 3 times root 10 on 4. Because we need to multiply 4 in this final fraction by 3 to get it to 12. So when we expand out all our brackets, remember when we've got this number in front of the brackets, we're multiplying both the numerator and the denominator by the number at the front. So that's going to leave us with 6 root 10 over 12 plus 4 root 10 over 12 plus 3 root 10 over 12. Now we can add everything together because the denominators of our fraction are the same. So we've got 6 lots of root 10 plus another 4 lots of root 10 plus another 3 lots of root 10, which gives us 13 lots of root 10 divided by 12. And that's our final answer for that one. So the next example here that we have, if we go right back to the top, we're now going to look at multiplying surds. So we've looked at adding and subtracting. Now what we're going to do is look at multiplying. And again, what we see is it works in quite a similar way to what we see with algebra. Okay, so again, we've got similar to algebra. And what we're going to do here is we've got something in single brackets. So we've got root 5 outside of the brackets, and we're multiplying that by 2 root 5 plus 3. So we're going to expand these brackets in the normal way that we would when we use algebra. Okay, so the first thing we're going to do is root 5 multiplied by 2 root 5. So this is step number 1. And this multiplication here is going to be step number 2, root 5 multiplied by root 3. Okay, and now when we're multiplying these surds, we can remember that if we don't have a number at the front of the root 5, it means that we've got 1 lot of root 5. So when we're multiplying surds, we're multiplying the coefficients or the numbers out the front. So 1 times 2 is going to be 2, and then we multiply these two surds together. Now, what we have is we're going to have 2 times root 5 times 5, okay, and then plus 5 square root of 5 times 3. Now the square root of 5 times 5 simplifies to root 25 plus root 15, okay, and that simplifies even further because 25 is a perfect square. So the square root of 25 is 5. So that becomes 2 times 5, which is 10, plus root 15. And that's the solution to that one there. Okay, so let's look at this second example. What we've got here is a similar example to what we have above. So we've got 2 steps. We've got this multiplication first, okay, and then we've got this multiplication second. So first thing we're going to do is negative root 3 times 5. So this is just an integer here. We don't have a square root or a surd here in this number. So when we multiply this by our surd, what we're going to end up with is negative, because remember this is like saying a negative 1, so we're going to have negative 5 root 3, okay, and then we've got negative root 3 multiplied by negative root 3. So that's going to give us a positive. Now square root of 3 multiplied by the square root of 3 just gives us 3, okay, and that's our answer there. We can't simplify that one any further. Okay, so let's look at this third example now. Now we've got double brackets. So we're adding a little bit of extra complexity here, and this is where you have to use your FOIL principles. Okay, so we've got 4 steps here to our multiplication to expand these brackets, exactly the same as the way that you would do it with algebra. This is going to be our step 1. This is going to be our step 2. This is going to be our step 3. and this is going to be our step 4 for our multiplications. Okay, so step 1 is going to be 2 multiplied by 2, which equals 4. Then what we're going to have is 2 multiplied by negative root 3. So we have negative 2 root 3. Then we've got positive root 3 multiplied by 2. So we've got plus 2 root 3. Then we've got root 3 multiplied by negative root 3. Okay, so what we're going to end up with there is negative. Now root 3 times root 3 is just going to be 3. All right, now we've got 2 surds here that we can add together and simplify because they've got a common surd here. Okay, so these 2 terms, the second and third term, have a common surd in them, so we can add them together and simplify them. Okay, same as the first and last terms, we can add them together and simplify them. So 4 take away 3 is going to give us 1, and we've got negative 2 root 3 plus 2 root 3. These 2 are actually going to cancel each other out. Okay, so the answer to that is just going to be 1. That's the solution to that problem there. Okay, so let's look at this one. What we have here is we've got 2 lots of brackets again, okay, indicated to us by this squared sign up here. So instead of writing the 2 lots of brackets out, they've just put the squared sign here. So if I write that out for you to explain exactly what that means, it's the same as saying this. Okay, so you've just got 2 lots. Oops, sorry, that should be a 2. You've got 2 lots of the same thing in those brackets. So again, we're going to do our FOIL and expand those brackets. So the first number is going to be our 3 multiplied by 3, which is going to give us 9. The next one's going to be 3 multiplied by negative 2 root 2. So that's going to be negative 6 root 2. The next one's going to be negative 2 root 2 multiplied by 3, which is going to give us the same thing, negative 6 root 2. And then the final thing is that we're going to have negative 2 root 2 multiplied by negative 2 root 2. So remembering that when we're multiplying these 2 surds together, we multiply the coefficients first. So multiplying those 2 coefficients together, negative 2 times negative 2 gives us positive 4. Root 2 times root 2 actually gives us 2. So we've got 4 times 2, which we can then just simplify to 8. Okay, so again, we simplify all these things down. 9 plus 8 is going to give us 17. Negative 6 root 2, negative another 6 root 2 is going to give us negative 12 root 2 as the solution there. Okay, final one for this slide. So another example of multiplication, again with our brackets, double brackets here, same process as above. Okay, so again, 2 root 5 times 2 root 5 gives us 4 times root 25, okay, plus negative, so we're going to have 2 root 5 multiplied by negative 6 next. So we're going to have negative 12 root 5, okay, 6 times 2 root 5, so we're going to have plus 12 root 5. And then we're going to have negative 6 multiplied by positive 6, which is going to give us negative 36. Okay, and if you're familiar with the different types of expansion of brackets, you'll notice that this is the exact same thing in these brackets with different signs in there, which is called the difference to squares, okay, which you may have heard that term used in maths, but you can always use FOIL whenever you've got these double brackets. Okay, so let's simplify it down now. Square root of 25 is a perfect square, so that simplifies to 5. So that leaves us with 4 multiplied by 5 is 20. Negative 12 root 5 plus 12 root 5, these again cancel each other out, okay? And then we've got negative 36. So 20 take away 36 is going to give us negative 16 as our answer for that one. All right, so now what we're going to look at is a different way to simplify surds. So what we've looked at is adding, subtracting, multiplying surds. How can we simplify surds down even more? Okay, so what this usually happens when we've got a larger number under our radical sign here. Okay, so the square root sign is actually called a radical sign. So I might just write that down. So this is called a radical sign, radical symbol. Okay, so let's look at these two different surds here. We've got the square root of 16 and then we've got the square root of 20. Okay, so hopefully most of you guys have picked up that the square root of 16 is a perfect square. So that's quite easy to simplify. The square root of 16, we can simplify quite easily down to 4 because it's a perfect square. However, when we've got something like the square root of 20, this isn't a perfect square. But what we can look for now is if this number 20 has a factor that is a perfect square. So let's have a think about all the factors of 20, okay? So if we start to list all the factors of 20, we've got 4, 5, 1, 20, 2, 10, okay? Now we look at those factors and we say, okay, are any of those factors perfect squares? And we should hopefully be able to identify this one here. 4 is also a perfect square. So what we can do is we can actually simplify this surd using the fact that one of its factors are actually a perfect square and using the rules of surd multiplication that we've seen previously. So we know from our surd multiplication that the square root of 20 is the same as saying the square root of 5 multiplied by the square root of 4. Okay? So therefore, we know that the square root of 4 is a perfect square, so that's 2. Square root of 5 we can't simplify any further, so that gives us root 5 multiplied by 2, which we then write like this. So now what we're going to do is we're going to look at some examples of how we can simplify these surds. Okay, so let's look at these examples here. We have, first example, we've got 2 root 7 squared. So the first thing that I'm going to do is write it out like this so that we know exactly what's going on. Then we're going to expand the brackets and simplify that down as much as possible first. So 2 root 7 multiplied by 2 root 7 is going to be equal to, multiplying the coefficients first, 2 times 2 is 4. Root 7 times root 7 is going to be equal to 7. 4 times 7, which equals 28. Okay, so that one there was quite easy to simplify. Let's look at the next one, 5 root 3 times 2 root 3. So what we've got here is just a straight multiplication again. We've multiplied the coefficients. 5 times 2 gives us 10. Root 3 times root 3 gives us 3. 10 times 3, which equals 30. Okay, so those simplifications were quite straightforward and easy. Okay, so this next one here starts to get a bit more complicated. We've got more than 2 things multiplied by each other now. So remember here we've got this little squared sign outside the brackets. So what that means is that we've got 2 root 3 multiplied by 2 root 3. And then we're multiplying that by 2 root 5. So whenever we've got 3 things like this, what I want to say is just take 2 at a time. So we're going to multiply these first 2 together first. So 2 times 2 gives us 4. Root 3 times root 3 gives us 3. So 4 times 3. This gives us 12. Okay, so now I'm going to take the 12 and I'm going to multiply that by this third thing here. 2 root 5. Okay, so 2 times 12 equals 24 root 5. So now we've got another example here. This time it's starting to get a little bit more tricky, and we have a fractional surd again. The other thing that we've noticed here is that this number 98 at the top, okay, this surd that we've got on the top here, is quite a large number. And we should know automatically, because it's an even number, that it's going to have some factors. So what we're going to do first is we're going to look at all the factors of 98 to see if we can simplify that surd by itself first. Okay, so let's look at all the factors of 98. And you might need to use your calculator for some of these because it's not always all that self-explanatory. Okay, so we're going to have 1 and 98. We're going to have 2 and 49. Okay, if 49 goes into it, then we're going to have a factor of 7 as well. Okay, 7. So we're going to have 14 and 7 as well. I'm not sure what other factors there are of 98. There may be some more that I've missed, but I do know that I've seen one that's a perfect square already. Okay, and it's this number 49 here. Okay, so we should pick up straight away 49 is a perfect square, so that's probably going to be the factor pair that we're going to use to help us simplify this surd here. Okay, so the way that we can simplify that is we can say that 3 times, now square root 98 is the same as saying the square root of 2 times 49. Our 2 root 2 is still there. Okay, now that's going to simplify now to 3 multiplied by root 2 multiplied by root 49 divided by 2 root 2. Okay, now the square root of 49 is going to simplify. That's our perfect square. That's going to simplify down to 7. Okay, so we're going to have 3 root 2 multiplied by 7 divided by 2 root 2. 3 times 7 is 21 root 2 divided by 2 lots of root 2. Now we can simplify this further. Okay, we've got root 2 on both the top and the bottom of our fraction here. We know that any number divided by itself is always equal to 1. So root 2 divided by root 2 is going to be 1. Okay, so they're going to cancel out straight away, which leaves us with 21 divided by 2. Okay, and that's the end of that question. So the last one here is some more examples of how we might simplify these surds. Or you might have the question written in such a way that it says, write in simplest radical form. Okay, so that means something that's got that radical symbol, okay, remembering that this is the radical symbol, in its simplest form, which means it can't be, whatever that radical is, can't be a smaller number, okay? So the first one here is we've got root 12. So this is where we need to look again at the factors of 12. So the factors of 12 are going to be our 1, 12, 2, 6, 3 and 4. And we're identifying again that factor that's the perfect square. And we've got 4 here. So that's the factor pair that we're going to be using to simplify this surd. So the square root of 12 is equal to the square root of 3 times 4. This equals the square root of 3 times the square root of 4, which equals the square root of 3 times 2, okay, which equals 2 root 3. All right. Again, similar with this second one here. Square root of 125, we're looking for all the factors of 125. Okay, so there's not going to be too many factors. We got 1 and 125. We can also have 25 and 5. And straight away here, I've seen my perfect square already. Okay, so we've got 25 as our perfect square. So we're going to use this factor pair here. So the square root of 25 can be written as square root of 5 times 25, which equals the square root of 5 multiplied by the square root of 25, which equals root 5 times 5, which we rewrite as 5 root 5. That's how we simplify those.